Hi and welcome to the fourth of four mini clips on nucleophilic addition elimination mechanisms, and in this final clip I'm just going to show you a few slightly more complicated looking examples, but some again which can be more simplified down to further examples of nucleophilic addition elimination mechanisms. The two examples I've chosen are Kevlar and also that of nylon. Looking at the nylon one first, we can again see that what we have on the left hand starting material of one of the two nylon reagents is this acid chloride grouping, and on the right hand molecule we can see this amine molecule. Now what we can immediately therefore hope to see is that what we have is lone pair of electrons on this nitrogen, which can theoretically attack here, which will then subsequently set up the addition elimination mechanism as we've seen in previous clips, which would, as before, eliminate this HCl molecule as an overall product. Again, if we'd used acid anhydrides, etc., we would have had that weaker ethanoic acid byproduct. But in this example, we've got a HCl molecule being eliminated from this, creating what would have been in here an amide linkage. It's where the nitrogen will be attached to that carbonyl. That is nothing different that we've seen on any of the previous clips in this series so far, but whereby these molecules have changed is that there is, as you can see, an amine on the other end of this starting molecule, and there is also another acid chloride on the other end of that starting molecule. This means that once this first amide linkage has been created, it is possible for this amine to then subsequently react with another molecule of the chloride which is in the reaction mixture. Likewise, this acid chloride could then subsequently react with another amine from another molecule in the reaction pot, so creating the possibility of polymerisation to occur, and subsequently nylon being known as a polyamide. But again, as I keep reiterating in these clips, at heart is a nucleophilic addition elimination mechanism. This is what we would see in a lot of biological systems, whereby the amino acids which react in biological systems, the amino acid being an example of a molecule which has an amine on one end but also a carboxylic acid on the other end of its molecule. So you can again have examples of polymerization. This is semi-indicated in the Kevlar example here. Now these two molecules are a dicarboxylic acid and also a diamine. These are not amino acids, but the fundamental chemistry is the same, as I keep pointing out. The difference here though is that the leaving group is slightly different to one we have seen before. But again, we've got a lone pair of electrons on this nitrogen which could interact here, allowing the oxygen to open up to create the O- ion, and subsequently the same steps as we've seen in previous examples. But the difference here, whereby the material we started with was a dicarboxylic acid, this means that instead of HCl being kicked out, or ethanoic acid in previous examples, this time we're simply eliminating water. So called when we get these, not strictly because it is water, but these polymerization reactions are also known as condensation polymers, whereby condensation polymers kick out, in this specific example, a water molecule, or more generically, they eliminate a small molecule during their reaction pathway. But these are, again, specific examples whereby at its heart, even though more complicated on the face of it, are simplistically addition-elimination mechanisms. And thank you for listening. If there's any more examples we need to look at, just let me know and I can go through them. Thank you.